So hi and welcome to our next video within our tutorials for modeling with RFEM 5. The content of this video will be creating and calculating truss structures. In RFEM we have basically two options for that. We can create trusses manually with individual single members, or we can simply generate a truss automatically using the model generator, which is a very time-saving option. In this tutorial, we will do both as an example. So we will begin with modeling the first truss with individual members graphically. The first step will be defining a new cross-section in the material. Let's say we choose this time an IP80 and as material steel S235. Then, as usual, we will set a new member and start modeling our truss graphically. So before we do that, I'd like to have a look at the member type to explain how a truss member is defined in our programs, RFEM and RSTEP. In one of our previous tutorials, I've shortly explained it. So until now, we mostly use the beam as member type, which transfers all internal forces. It's a fully fixed member without any member hinges, and this is still what we need for the upper and lower chords of our truss. Then we have several other options for member types, and we can find a truss here. And a truss is defined as a beam member, but with automatically applied moment and releases. So a truss is a beam with member hinges on its member ends. And this is great for all of the internal members within our truss, like the diagonals, because we don't have to define member hinges manually on each member ends anymore. But first, we will begin with the upper and lower chords with the standard beam member. So our truss will have a total length of 6 meters and a height of 1 meter. And now for all the remaining members, including the diagonals, we will select new single member up here again, and then we change the member type to a truss member. We will insert in total 6 diagonals, beginning in the middle with a distance of 1 meter in between. First this side and then the other side. Once done, next we need our 2 supports. We will have a hinged one at the start point, and the one at the end will be able to slide along the X direction. Now, as we can see, our truss structure is finished, and we can start with our second example, which will be generating a truss automatically using the model generator. First, we will create a new node, and this node will be the starting node of the truss later. Then, in order to generate any structure, we can go up here to Tools, and then we can find Generate Model Members. We can see that some of them are grayed out. This is because we are still in a 2D environment. That doesn't matter for our example, because we will choose the option 2D truss here. Next, this dialog appears, and what we can do in this dialog is we can select here different truss types, we can set different directions for the diagonals, and then we can define the geometry and cross sections, member types, materials, and so on. So for our truss, we will choose the first truss type as an example. For the diagonals, we will choose this one, according to our first example. And then down here we can see the final truss structure. On the parameter, we can set the geometry of the truss. For the number of bays, we can type in 6. The total length will be, let's say again, 6 meters, and the total height will be 2 meters. The side height will be 1 meter. Then we can determine the cross-section and member type. And we can see here the program automatically suggests us the member type. That's very helpful. For the upper and lower chords, a beam member is defined, and for the diagonals and verticals, truss members are set on default. Since we only have one cross-section type, the defined cross-section is also set here automatically. And of course, we could simply change this by opening up the library or creating a new one. But for this example, we will stay with this cross-section that we also have for our first truss. Then we will choose the node where the first point of the truss will start. And now we can see the generated truss structure also in the graphical area. Next, we will apply a point load of 100 kilonewtons in the middle of both truss structures. By clicking calculate all, our results will be displayed as we can see now. And with that said, thank you for watching again. The next video will be about modeling arc structures.